All right, so going into our two variable inequalities, we've got a few things that we're going to do. First of all, we're going to write some two variable inequalities from word problems. We're going to convert two variable inequalities to slope-intercept form. Yes, that's something that we can do even with inequalities. And then we're going to identify solutions to those two variable inequalities, so kind of building off of our last video. So first, Josh is baking a multi-tiered cake for a friend's wedding. An 8-inch cake tier will feed 19 guests. That looks important, so I'm going to go ahead and underline that. And a 12-inch tier will feed 39 guests. Also looks important, so I'm going to underline that. In total, these tiers must feed 244 guests, the number that is attending the wedding. So, my first question is asking me how many rates of change. And I can see that there are two different rates of change, and let's go ahead and identify those because that's what our second one is asking us to do. What are those rates of change? So my first rate of change is an 8-inch cake tier will feed 19 guests. So our first one is 19 guests per 8-inch tier. Let me go ahead and rewrite guests here so it's a little bit better. Alright, so 19 guests per 8-inch tier, which then makes my other rate of change 39 guests per 12-inch tier. Alright, so I've now identified my two rates of change. If I have two rates of change in a problem, that normally means I'm going to use standard form. So we're going to get to that in just a moment. But first, I need to define my variables. So what means what? I can see here that I'm going to have to figure out which combinations are going to feed the guests. So if I'm going to try and figure that out, I need to know how many 8-inch cakes and how many 10-inch cakes are needed. So those are my variables because I don't know those now. And in place of something we don't know, we're going to use a variable. So I'm going to say x is equal to the number of 8-inch cakes and y is the number of 12-inch cakes. Alright, so now I need to write an inequality in standard form. So just like inequalities, our equations are going to follow the same pattern, ax plus by. So let's go ahead and write our inequality in standard form. So first of all, I've got my ax. I'm going to use my rate of change for my x variable. My x variable here is the number of 8-inch cakes. And I know that the rate of change for my 8-inch cakes is 19. So I've got 19x. And then I'm going to add to that my y variable, my 12-inch cakes. So my 12-inch cakes are my y variable, and the rate of change for that is 39. So I've got 19x plus 39y. Now when I'm writing an inequality, I need to figure out, okay, what inequality symbol am I going to use? Because unlike equations, there's not just one. We've got 4 different ones that we have to choose from. So I can see that this needs to feed at least 244 guests. So if I'm going to be comparing that number to that 244 guests, I'm going to need to say, all right, on the left side here, this is my cakes, and that needs to be greater than or equal to the number of guests, because it has to be at least that number of guests. So my inequality then is 19x plus 39y is greater than or equal to 244. Now, we're not quite done yet. We've still got a couple more steps here. So we need to next convert to slope-intercept form. So in order to do that, that means we need to isolate y. So we have 19x plus 39y is greater than or equal to 244. So now, in order to isolate y, we want to get y by itself. Now, normally we would put our inequality symbol here, or equal sign here. But we have to remember that if we multiply or divide by a negative number, we need to flip that sign. So we're going to keep that in mind as we go along, that inequality symbol might change. So in order to get y by itself, we need to get rid of our 19x. We've got 19x, so we're going to subtract 19x. And then I know in slope-intercept form, we're going to have that negative 19x first. So we'll say 39y is greater than or equal to negative 19x plus 244. All right, the next thing we need to do is we need to get rid of that 39. We're going to get rid of that by dividing by 39. When we divide by 39, we need to divide everything by 39. So we would have y is greater than or equal to negative 19x divided by 39 plus 244 over 39. So now the last thing that we need to do is we need to figure out which combinations of cakes will feed all the wedding guests. And it says select all that apply, so we need to check all of the scenarios. Now, we can substitute into our slope-intercept form here. That's one way that we can do this. But it looks to me like it might be easier for us to use our standard form up here. So I'm going to use my standard form when I'm trying to substitute in, just because I think it's going to be a little bit easier for me to do that math. I don't have to deal with this really big fraction here. So we're going to use that 19x plus 39y. So we've got our first problem. We have 19x. Now, x I see represents the number of 8-inch cakes, and I'm going to be using 10 8-inch cakes. So I have 19 times 10 plus 39y. Now my y is the number of 12-inch cakes, so we've got one of those. 39 times 1 has to be greater than or equal to 244. Oh, and I just ran out of room here. So let's go ahead and rewrite that. So we've got 19 times 10 plus 39 times 1 is greater than or equal to 244. All right, 19 times 10 is 190. 39 times 1 is 39. 190 plus 39 is 229. 229 is not greater than or equal to 244, so we know that this one is not correct. Now let's go ahead and substitute into our next one, because once again, we need to find all of them that apply, so we're going to try all of these. Our next one, 3 8-inch cakes, so we have 19 times 3 plus 9 12-inch cakes, so that's 39 times 9 is greater than or equal to 244. (19 times 3) we would say is 57 plus 39 times 9, and we can take that 39 times 9 and put it in a calculator. We'll get 351 is greater than or equal to 244. That's true, because I know that 57 plus 351 is going to be over 400. So we've got that one true. And then we're going to go ahead and check our last one here. So as we check our last one, I'm going to just change colors so that way we can try and keep these straight. So we've got 19 times x. Our x value is our 8-inch cakes. We have 5 8-inch cakes here, so 19 times 5. And then 8 12-inch cakes, so plus 39 times 8 is greater than or equal to 244. Let's see, 19 times 5, 95, plus 39 times 8 is 312, is greater than or equal to 244. Once again, I can see here that we're going to have over 400 pieces of cake here. 95 times 312 is 407, is greater than or equal to 244. That's true as well, so we're going to say that our correct answers are the last two, and that finishes up our problem.